Before the early 21st century, most scientists proposed one of two scenarios for the formation of Jupiter. If the planet accreted first as a solid body, it would consist of a dense core, a surrounding layer of liquid metallic hydrogen, with some helium, extending outward to about 80% of the radius of the planet, and an outer atmosphere consisting primarily of molecular hydrogen. Alternatively, if the planet collapsed directly from the gaseous protoplanetary disk, it was expected to completely lack a core, consisting instead of denser and denser fluid, predominantly molecular and metallic hydrogen, all the way to the center. Data from the Juno mission showed that Jupiter has a diffuse core that mixes into its mantle. This mixing process could have arisen during formation, while the planet accreted solids and gases from the surrounding nebula. Alternatively, it could have been caused by an impact from a planet of about 10 Earth masses a few million years after Jupiter's formation, which would have disrupted an originally solid Jovian core. It is estimated that the core takes up 30 to 50% of the planet's radius, and contains heavy elements with a combined mass 7 to 25 times the Earth. Outside the layer of metallic hydrogen lies a transparent interior atmosphere of hydrogen. At this depth, the pressure and temperature are above molecular hydrogen's critical pressure of 1.3 megapascals and critical temperature of 33 K. -240. 2 degrees Celsius. -400. 3 degrees Fahrenheit. In this state, there are no distinct liquid and gas phases. Hydrogen is said to be in a supercritical fluid state. The hydrogen and helium gas extending downward from the cloud layer gradually transitions to a liquid in deeper layers, possibly resembling something akin to an ocean of liquid hydrogen and other supercritical fluids. U-200A22, U-200A physically. The gas gradually becomes hotter and denser as depth increases. Rain-like droplets of helium and neon precipitate downward through the lower atmosphere, depleting the abundance of these elements in the upper atmosphere. Calculations suggest that helium drops separate from metallic hydrogen at a radius of 60,000 kilometers, 37,000 miles, 11,000 kilometers, 6,800 miles, below the cloud tops, and merge again at 50,000 kilometers, 31,000 miles, 22,000 kilometers, 14,000 miles, beneath the clouds. Rainfalls of diamonds have been suggested to occur, as well as on Saturn and the ice giants Uranus and Neptune. The temperature and pressure inside Jupiter increase steadily inward as the heat of planetary formation can only escape by convection. At a surface depth where the atmospheric pressure level is 1 bar. 0. 10 megapascals, the temperature is around 165 K. -108 degrees Celsius. -163 degrees Fahrenheit. The region where supercritical hydrogen changes gradually from a molecular fluid to a metallic fluid spans pressure ranges of 50 to 400 gigapascals with temperatures of 5,000 to 8,400 K. 4,730 to 8,130 degrees Celsius. 8,540 to 14,660 degrees Fahrenheit, respectively. The temperature of Jupiter's diluted core is estimated to be 20,000 K. 19,700 degrees Celsius. 35,500 degrees Fahrenheit, with a pressure of around 4,000 gigapascals.